So from this, right, you know two things. This question doesn't involve heat transfer, and it doesn't involve change in volume. Okay, so you can also see that in the assumption lah. But of course, again, for us, in this case, the main assumption will be number 1 and number 2. 3 and 4, not too necessarily to put in the assumption, but of course, if you want, you can. Or for exam, let's say exam, if this question comes out, 1 and 2 will be the one that I'm looking for lah. Okay, so initially contains 0.7 kg of helium at 27 degrees Celsius and 350 kilopascal, and you have a paddle wheel. So let's say if we are writing this equation, okay, we know that this is a closed system. So for closed system, we always start with this equation. So we single out what we have here. So obviously we know that there's no Q. So minus work out minus work in. So in this case, what we have will be work in, right? Because you have a paddle wheel that is stirring the tank. So meaning you will have work in, or maybe shaft work, equals to U2 minus U1, which actually, yeah, so what we will see this in the next slide lah. Okay, so in general, so let's say if you start with this, then this will be the equation that you get. So here you will see that obviously you need to find all these three things. So the first thing that we can find will actually be the shaft work. Okay, so when we are dealing with closed system here, again, always remember this. Usually for closed system, we deal with it in terms of energy. So meaning no rate here, because it is just mass. Essentially this one will just be mu2 minus u1, not mass, not m dot, because we don't really have a flow in a closed system. So closed system usually would be in terms of kilojoule, not kilowatt. So what you're given here is the paddle wheel in terms of kilowatt, that's the power rating, and it moves for 30 minutes. So first thing, now, so we look at this, so here we actually gave you how the graph will look like as well in terms of PV diagram. So volume doesn't really change. So when volume doesn't change, you don't really have a boundary work, right? So PV graph, you can see that there's no area under the graph here as well, because it's just a straight line up. Okay, so we convert the work shaft or the work in to the kilojoule first, because that's the power rating with the time. So 27 kilojoule, that's what we have. Alright, so then we sub in into this equation. So this was what we derived just now. So there's no Q because this is insulated. We only have work in, so the work in become positive in this case because of the minus outside. So what we have here is WE equals to delta U. So this WE is the work shaft. Okay, so since this is the ideal gas, we also know that delta U is equal to MC delta T or MCV delta T, because we are looking for delta U here. So we can actually sub this into the equation. So 27 would be the work in or work shaft. 0.7 is the mass of the helium. CV value you can get from table A2 just now, or okay, so here actually I think I make a slight mistake here. No, not actually. 300 Kelvin. So here, if you use table A2, yeah, A, because it was at 300 Kelvin, right? 27 degrees Celsius. So helium, just look for this CV value. Okay. So here you get a CV value. You can sub into the equation. You will get the final temperature, which is 39.4 degrees Celsius. So for temperature change, actually if it is a minus or difference, you don't really need to convert it to Kelvin, because the 273 will just cancel off. But of course, if you are easily confused, then you just convert it to Kelvin, then convert back if you want to. Okay, so now we got the temperature. So once you have gotten the temperature, what's the subsequent question here? So the next question would be the final pressure. So for the final pressure, then what can you do here? Can anyone think of what to do here? You got the temperature. Temperature should be very straightforward because it is actually just what you learned for the closed system. Change delta U to MC delta T, that's all. But how do you find the pressure here? Or just note, also note that the ideal gas equation table, right, the A17, don't really give you pressure value or volume value because gas can be any volume or pressure. Can anyone think of how to find pressure here? We're dealing with ideal gas, right? So, ideal gas equation. So PV over T equals to PV over T. We know that volume doesn't change, so volume get cancelled off. So you are left with PT over PT, and you do have P1, T1, and T2. So you can solve this. But of course, again, when you use ideal gas equation, remember to convert everything into Kelvin. Okay, so this way you will be able to get the pressure. If you don't convert Kelvin, then your pressure value will be off lah. Okay, so this is where I will stop. Again, the other example we'll finish this up on Thursday. Yeah. So if you have any question, you can ask now. If not, you are free to leave.
That's good.